alternate form of an element having a different number of neutrons in its nucleus, hence having a different atomic mass but no change in chemical properties. When a form of an element contains a different number of neutrons, however, transmutation occurs, the conversion of one chemical element or isotope into another. Sounds like an alchemist's dream, right? Well, with knowledge of transmutation, it actually is possible to induce transmutation and turn lead to gold by bombarding elements with high-speed particles or ions using an accelerator, but it is far too expensive to be financially viable. Transmutation happens in nature in radioactive decay chains. Radioactive decay is the process by which the nucleus of an unstable atom loses energy by emitting radiation. The half-life equation answers the question of how long it takes for half of the nuclei of any sample to undergo radioactive decay. This varies greatly between radioisotopes. The positively charged protons in the nucleus are repelling each other. When the forces that hold them together can no longer do their job because the nucleus is unstable, the nucleus breaks apart, undergoing radioactive decay. Energy is lost by the emission of an ionizing particle and radiation. There are three main types of radioactive decay: alpha, beta, and gamma, which usually occur in a combination. In alpha decay, the nucleus emits an alpha particle with the same configuration as a helium nucleus, thereby transforming into an atom with a mass number reduced by 4 and an atomic number reduced by 2. This is the least dangerous form of radiation and can be stopped by a piece of paper. Beta decay occurs when a proton is transformed into a neutron or vice versa, allowing the atom to move closer to the optimal ratio of neutrons and protons, and an electron is emitted. It is still unable to penetrate human skin. Gamma decay occurs when the nucleus changes from a higher energy state to a lower energy state through the emission of electromagnetic radiation. The number of protons or neutrons does not change, so the parent and daughter atoms are of the same chemical element. Its position on the electromagnetic spectrum demonstrates that gamma radiation is very high frequency. And while this means exposure is dangerous, it also makes them useful in radiation therapy.